welcome in. So I wanted to make this video just to give you a few ideas with regards to electric kind of conduction or conductors in general, and then trying to talk about kind of electric induction. So inducing by basically not necessarily physical touches, which typically conduction will be. So I want to distinguish between these two things, and I also want in this video to talk about grounding and kind of introduce you to the concept of grounding and then what is happening. So by now you should be aware that when you're talking about charges, so we have positive charges and negative charges, so we know that like charges will repel each other and unlike charges will attract each other. And whenever possible, so by nature, the idea will be that any objects will like to stay as neutral as possible, meaning they don't really want to have a charge on them. So they want to just be neutralized, unless, of course, there's something preventing it or something is happening. Now, sometimes we do want certain charges, okay, to be present. So in conduction, or conductors, where charges flow very easily. Now, when we say charges, I'm actually going to just refer, and I would want you to think about these charges as simply electrons, right? So electrons being able to kind of flow as they're going through. So we'll kind of simplify it in that particular form. And those electrons, okay, can be designated, so typically with minuses or with a, little e with a minus, okay? So in that particular way, so here's, maybe an electron, okay, or some negative charge, or maybe in this way, or sometimes, you might see it as a Q, okay, with a negative charge, and then positive ones, okay, are just going to be positive, okay, or sometimes like this, or sometimes even the positive is dropped, or you can have a positive charge. You can have a capital Q as well. So now our concentration is right here. So we want to be able to see, all right, so how are these electrons and where are they moving around and how are they moving around? So if you physically touch something, then you can understand that through that conduction, okay, so that through that physical touch, so that contact, electrons can flow from one item to another. And because they want to be neutral, or they want to maintain, okay, as much neutrality as possible, so whenever they are touched, okay, and let's say one object is charged and the other one isn't, okay, they'll try to transfer and balance each other off. So now conductors, which allow these electrons to flow very easily, can allow these things, and hence, typically there's some kind of metals that we have, and you may know that, copper is one of them. It's not the only one. I mean, gold is actually better as a conductor, but it just would be very expensive for us, okay, to do that. But copper is, reasonable enough that we can have electrons flowing through them. So now, with respect to grounding and electrons, so this is something that I would want to refer. So very often, so in terms of grounding, what do we mean? Well, the ground itself, so, if I draw the ground right here, okay, and, so very often might be drawn like this. Now, in electrical kind of circuits, or in electricity in general, so the ground itself, and yes, I am referring to the ground, okay, the earth, okay, as a whole. So this is typically given this particular symbol, right? So that you have there, and basically things are grounded, and electrons can flow into the ground or they can flow out of the ground, depending on what the charge might be. So for instance, if this is the ground itself, okay, and then you have a wire which is connected to something, okay, and then that, okay, let's say it's some kind of a ball and it is positively charged, and then you try to, connect that wire to the ground, then the electrons are going to start coming back up here to try to neutralize this. If on the other hand, okay, so if instead what you would have is that this would have been negatively charged, well, then the electrons are going to try to flow out, okay, from here and into the ground, so that it can, as best as possible, to try to neutralize this, and so that it doesn't really have a charge. So that is very often called grounding. So electrons can flow into the ground or out of the ground. Now, the Earth is so massive that it doesn't really do much, okay, if it loses a few electrons, or even, quite a bit of electrons, because it's just so massive that electrons can flow in and then they can flow out. And then we do have to be careful, okay, when we're touching, because we can touch something that's actually charged and it can discharge through us, and obviously that's a problem. Okay? Or, you know, the electrons can come up through us into the object. Okay? That's also a problem. Now, these are all kind of conduction or through contact base. Now, what would happen, right? And if we wanted to be able to distinguish between conduction and induction in here. Well, so induction is not through touch at all. So conduction is kind of like thermal conduction, where you're transferring heat and basically there's physical contact between two items and then the heat just transfers. While induction works in a way that you don't have this physical contact. Now, how can that possibly happen, you might think? Well, so for instance, you know, one of the examples in terms of conduction, so what I'm going to just show you, is something like this. So for instance, you know, what if we did have this particular ball? So let's say, you know, I had something like this, and near it, you know, maybe I was holding some kind of an item, so it doesn't matter what it is, it can be some kind of a rod. And let's say that this was negatively charged, okay, within here. Now, if this ball is, you know, outside from anything else, so what would happen is that even if this was neutral, then, you know, what will happen is that, you know, the positive charges, okay, would kind of appear on the other side, okay, that you would have. And if it was negative charged over here, then these things would start to repel each other. But what is going to start to happen is within here is that, well, it's going to be the opposite that it will want to do. So the electrons will want to get away as far as possible because like charges repel, and therefore it will technically leave the other side positive in here. So it will do that. Now, but notice, but there wasn't really any charge here, right, that we've had. So, you know, so you basically kind of, this is called polarization. So you polarized this particular object, and this is induced because there is no physical touch here, okay? There is just an item which is charged, and if you bring it close enough in here, then these electrons are going to try to get away from here because these are repelling each other. So that's one form of polarization. Now, what if, you know, we wanted to do something, okay, and we still wanted to hold this, you know, charge within there, and now all of a sudden, you know, we put another ball in here. So if I duplicate this, I'm going to duplicate it like this, okay. Now, what would happen in this case, and let's say that these two things are touching. Well, what's going to happen is that, you know, these electrons, okay, so basically because these two balls are in contact, well, then the electrons are going to try to get away as far as possible. So they are going to create polarization in this way. And now, all of a sudden, what you can do is you can remove, okay, now I'm not going to tell you how you would do this, okay, per se, but let's say, you know, if you would understand this. So now, as long as this is close by, and when I say this, I mean this right here. So if this is still close by, and now if I magically say that, okay, well, I'm going to remove the contact in here. So notice that you've induced the two charges right here. So now all of a sudden, you know, this might be negative and this one might be positive. Now, if these were positives in here, then the opposite would happen right here, where the negatives would come closer. But you've now induced the charged over here, and now you have two of these balls. Now, if you bring them back together and then you remove the actual, okay, so this particular rod, then, you know, it'll neutralize itself once again. But now, if you remove this entirely, you now still have two of these charged. So it's kind of one way that you can provide induction, okay, so inducing a particular charge. Now, another way that you can do this is through something in terms of connecting it to the ground. So you can, for instance, let me remove this particular ball in here. So you can do something like this. You can say, all right, let me kind of take this down and attach it to the ground with a wire. And if you have this, well, then what's going to happen is that the negative charges are going to try to get away here, and they're going to come down, and then therefore, you know, leaving this more or less more positively charged, depending on, you know, how huge this particular charge is here. So now as these things go away, and now let's imagine that you now cut off, okay, this particular grounding, so I'm going to delete this entirely. Well, now, okay, the electrons, so basically they've gone down to the ground, and you've now once again charged this particular object. Now, this would be positively charged, and if it was negatively charged, meaning if this was positively charged, this would become now negatively charged, where the charges from the ground would come up. And if you cut the wire out entirely, you would basically induce that charge without any contact charges. So that's what induction is, and it does happen, okay? And we can certainly do that, in particular in the cases where we want to polarize things. So even if you have, two charges, it doesn't matter how far they are, the actual electrons, okay, want to try to get away, so they want to try to move as far away as possible. And that's because there's actually electric forces that are present, and you're going to learn that, shortly, okay, as you kind of watch, for example, Coulomb's forces law, okay, that you have between charges. So there are actual, because the repelling and the attraction, well, that is just pushes and pulls. So it works very much like gravity, where it starts to push and pull things away depending on what the charges are. All right, so that's what I wanted to discuss in this video. I was contemplating making this video or not, but I think for students it's worthwhile to understand the difference between conduction, where there is actual charges, okay, and the charges are transferring, and that's through direct contacts that you have. Now that's not very hard to understand, okay, when you have that. So you can certainly do it through a charge, okay, in that way, where you can touch one item and another, and then the electrons can flow either to the object or out of the object through contact. But what's a little bit harder to understand is the concept of induction, where you're not technically charging, but you saw here a few examples. I would encourage you can take a look. I'm sure you're going to find others, okay, on the web or somewhere else in your textbooks, where you can talk and discuss this. And this is everything to do because charges, okay, either repel or attract each other, and it has this wonderful property, okay, to do that. Okay, the other concept that I want you to remember is definitely grounding. So grounding in terms of the earth itself being the ground, and the symbol that you've now been introduced, that you're going to see quite often if you continue on studying electricity, and even magnetism. All right, so thanks for watching. Okay, we'll see you in future videos. Happy studying. Bye, everyone.